the universe. It is filled with deep mystery. Every day, there are discoveries. Some of them are strange, and some of them are frightening. And that is what we will discover in this video. Welcome back. Today we're exploring a new discovery about the solar system. So let's get started right away. Don't forget to show your support by liking and subscribing. Thank you all. Neptune, the hidden storm at the edge of the solar system. Neptune looks serene from a distance. A smooth, glowing blue marble hanging at the outer edge of the solar system. But that calm is an illusion. Beneath its cloud tops, Neptune is one of the most violent places astronomers have ever observed, and deep in its interior may lie one of the strangest phenomena in planetary science. Rain made of diamonds, a world found by Math Not Telescope. Neptune is so far away, roughly 4.5 billion kilometers from the Sun, about 5 times farther than Jupiter, that it's invisible to the naked eye. For most of human history, we simply didn't know it was there. It wasn't discovered until 1846, and even then, no one actually spotted it through a telescope first. Astronomers noticed that Uranus's orbit was behaving strangely, as if something unseen were tugging at it. A mathematician used that irregularity to calculate where the mystery object had to be, and when a telescope was finally pointed at that exact patch of sky, Neptune was sitting there waiting. For over a century after that, almost nothing more was learned. Neptune and its neighbor Uranus, the solar system's 2 ice giants, were simply too distant and dim to study in detail. One spacecraft, one chance. Nearly everything we know about Neptune today traces back to a single spacecraft, NASA's Voyager 2. It reached Neptune in 1989 during the tail end of its grand tour of the outer planets, made possible by a rare planetary alignment that only occurs once every 200 years. Voyager 2's instruments were modest by today's standards. Wide-angle and telephoto cameras with color filters, plus infrared and ultraviolet sensors to measure temperature, density, magnetism, and radio emissions. It had visited the eerily still, featureless world of Uranus 3 years earlier, which led some scientists to wonder if the outer solar system's excitement had ended at Saturn. Neptune proved otherwise. As Voyager 2 closed in, it revealed a brilliant electric blue planet racked by extreme weather. Neptune has the fastest winds ever recorded on any planet, about 5 times more powerful than Earth's strongest tornadoes, with gusts that can exceed the speed of sound. Voyager spotted a storm the size of Earth itself, nicknamed the Great Dark Spot, with winds clocked at over 2,400 km/h, compared to roughly 500 km/h in the strongest storms ever measured on Earth. That level of violence is puzzling, because wind is driven by temperature contrast, and Neptune receives only about 1,000th of the sunlight Earth gets. Yet its clouds are slightly warmer and far more active than those of closer-in Uranus. Something inside the planet must be generating heat. To explain that heat, scientists look inward. Neptune is the densest of the giant planets. Below its hydrogen, helium, methane cloud layer lies a thick, slushy mantle of water, ammonia, and methane, wrapped around a solid core of rock and metal, roughly Earth-sized but about 50% heavier. The deeper you go, the more crushing the pressure becomes, reportedly around 7 million times greater than Earth's atmosphere near the core. Under that kind of pressure, the carbon inside methane molecules is thought to crystallize into diamonds, which then sink like rain through the mantle toward a liquid layer so dense that even solid diamond can float. The friction generated as these crystals fall is one leading theory for where Neptune's internal heat and its record-breaking winds comes from. It remains a theory built on limited data, but a compelling one, and something similar may be happening more faintly inside Uranus. Neptune's largest moon, Triton, is a mystery of its own. Unlike most moons, it orbits at a steep tilt and moves backward relative to Neptune's rotation. a trait no other large moon in the solar system shares. That backward, or retrograde orbit is the key clue that Triton isn't a moon that formed alongside Neptune at all. It's now thought to be a captured dwarf planet, once half of a binary pair similar to Pluto, torn from its partner and pulled into Neptune's gravity roughly 4 billion years ago. Neptune has a habit of doing this. Over billions of years, its gravity has scattered countless similarly sized icy bodies out into the distant ring of debris known as the Kuiper Belt, the same region where Pluto resides, and part of why Pluto is no longer classified as a full planet. Triton's fate is grim. Its unstable orbit is slowly decaying, and eventually Neptune's gravity will tear the moon apart. The debris is expected to spread into a ring system that could rival or exceed the rings of Saturn, though this won't happen for a very long time. After its Neptune flyby, Voyager 2 left the planets behind for interstellar space, and no dedicated mission has followed it to the ice giants since. NASA has floated a concept called Neptune Odyssey, which would orbit Neptune and Triton for years and drop a probe into the planet's atmosphere to gather data before being crushed by the pressure. For now, that remains a proposal rather than a funded mission. Nearly 40 years after that one close flyby, Neptune remains largely a puzzle. A planet we understand mostly through inference, theory, and a handful of hours of data gathered by a single spacecraft passing through on its way out of the solar system.